This is the part C of the fourth video in the trigonometry set. And this, so part four is trigonometry 4 is about trigonometrical identities and equations. So I've split this up because it's quite a big topic. And so this part C is dealing with how we solve equations which are of the form of a linear combination of sines and cosines. Now, this also is addressed under transformation of graphs, which is kind of another aspect of it. But it could be that we get an equation to solve, which is of this form here. 2 sine theta minus 4 cos theta. Now, this is kind of also handled under something called the R formula. It's sort of generally called in sort of a level teaching as the R formula because it alludes to the method by which these are resolved. But our formula doesn't kind of say what it's about terribly well, but that's what we tend to use in common usage, the R formula. So, okay, so let's have a look at what we're talking about here. Express 2 sine theta minus 4 cos theta in the form of this, where r and theta are constants. R is greater than 0 and alpha is between 0 and pi over 2. So this is kind of the first part where sort of establishing an an identity. There's an alternative way of phrasing this, and then that's going to lead on to an equation, which I actually haven't got in this little panel here. But okay, let's have a look. So now if you were to go to, say, Desmos or some other graphing tool and graph 2 sine theta minus 4 cos theta, you will actually, you get something that, well, it looks exactly like this in actual fact. So and this, what does it look like? It just looks like another sine curve or a sine curve or a cosine curve, doesn't it? With a couple of differences. First of all, when we look at the amplitude of this, it's just over 4, isn't it? 5? Yeah, it goes to 5. And 2, 4, 4 point something anyway. And also it's shifted. It's not a sine curve because it doesn't start off at 0, nor does it start off here. This peak is not actually on the y-axis. It's actually been shifted and stretched. It's a shifted, stretched sine curve, or a shifted, stretched cosine curve, if you like. So what can we do? Well, this is what we do. We want to actually express it in this form here. Now, when it's in this form here, we can, the sort of corresponding equation that we get, which might be like this down here, looking ahead, 2 sine theta minus 4 cos theta equals 2. Then if we can actually change this left-hand side into a single trig function like sine, then we will be able to solve this equation. Right, so let's just have a think about this. So this is what we've got here. Now we've got our two angle formulas we can use. So if we were to expand this out, we're going to get r sine theta cos alpha minus r cos theta sine alpha. Right. Now, if we were to compare this to this by comparing coefficients, we can see that the coefficient of sine theta is r cos alpha here, and it's 2 here. Similarly, the coefficient of cos theta is r sine alpha here, and over here it's 4. Okay, So 2 equals r cos alpha, and 4 equals r sine alpha. Right. Well, we've got a sort of a simultaneous equations here. And from this, we can glean that tan alpha is going to be 2, and that's going to give us alpha is 63.43 to 2 decimal places. It does say that alpha is between 0 and pi over 2, so we've got our solution here. Then if we square both of these coefficients, r squared sine squared alpha, so I'm not squaring that one, and r squared cos squared alpha, so I'm squaring that one, then we get 4 squared plus 2 squared. So on the next line, I'll factorize this out. Factorize out r squared, because we know this is 1, because this is one of our standard identities. So in other words, r squared equals 20, and r equals 2 root 5. So our 2 sine theta minus 4 cos theta is actually r sine theta minus alpha, where r is 2 root 5 and alpha is 63.43. Okay, so that is the basic gist of it. Now, if we want to solve this, then we can solve this instead. So we've basically just done our identity shift, if you like, from that to that. And using the methods that we've been through before, we can actually now solve this. So I've not I've not worked this one right through, but sine theta minus 63.43 equals 1 over root 5. So this is a single factor equation now, and we can just solve it using the method that we had used before. Okay, so that is basically it. Now, as I say, this is also treated under transformation of graphs. So there's another video in the trigonometry section which gives another example of it. Essentially, if you came across that kind of equation, then we can use this method, this kind of R formula method, to actually solve it. So hopefully that has been of help, and thanks for listening.